Have you ever thought what material holds up your house, your office, the roads you travel on every day? The answer is concrete. In fact, more than 90% of the world's built environment depends on concrete. And the most important ingredient of concrete is cement. Cement supports millions of jobs, enables low-cost housing, and drives urban development, especially in countries like India, the world's second largest cement producer. But here's the problem no one talks about. Cement is also one of the biggest contributors to climate change. Producing just 1 ton of cement releases about 0.66 tons of CO2. That's roughly equivalent to driving a petrol car from Kashmir to Kanyakumari. Now multiply that by 4.1 billion times, because that's how much cement is produced every year worldwide. And demand is still increasing. So clearly, if we want sustainable development, we cannot ignore how cement is produced and monitored. One major issue lies in quality control.
Traditional X-ray quality checks take hours, resulting in delayed intervention, high energy use, and significant material loss. There are conventional models like century-old Bogue equations. They assume steady-state conditions and can exceed 20% error, making them unsuitable for real-time quality control.
By the time defects are detected, large quantities of material may already be wasted, leading to reprocessing, higher energy use, and more emissions. This is where artificial intelligence comes in. At IIT Delhi, a research team led by Mr. Sheikh Junaid Fayaz, under the supervision of Professor N.M. Anoop Krishnan, has developed AI models that can predict clinker quality in real time.
We achieve unprecedented accuracy, 5 to 6 times more than previous industrial models.
Our AI models can tell you the quality of the clinker within fractions of a second. So basically, we bring down the quality control time from 4 hours to fractions of a second. During this 4-hour delay, if the plant is operating suboptimally, producing ineffective clinkers, the entire 4-hour production is either recycled or goes to waste. This is a huge material wastage, and not to mention the additional CO2 emissions which are released due to this ineffective production.
The research is already published in Nature's Communications Engineering and also featured in Nature Review's Clean Technology. Because of the success and scope of this research, cement plants across the world have already shown interest in adopting AI-based systems. So the next time you see a building rise, remember, the biggest climate solutions are not about stopping development, but about making development smarter.